uses lists rather than arrays, but the key difference to that is that an array is a fixed length, while a list can grow and shrink as required. So in Python, a list starts with no data in it at all, and then you start adding items one to it at a time. And in an array, you just allocate it to a certain length, and it's that length forevermore until you reallocate it. But there's a way you can get Python to do an array rather than a list. You can get it to pre-allocate, a certain number of spaces by doing something like this. I'm just going to use A for array. And then you give it a data type, a value, and you say, okay, but I want 100 of them. So we've already seen that that's how you allocate a list in Python, right? Is between the square braces, and then you can put some numbers there or something like that. What this just did is create something like that that was 100 long. Obviously, I'm not going to type 100 of those. And so we're going to use that today to create a list, an array of a certain length, rather than go through and add items to it by hand. If you're going to add items to it by hand, once you have your list created, list.append will add another, item to the list. So if you have a list of books and you want to tack one onto the end, list.append will do it. So these slides are kind of hard to see, so you may want to open up the PowerPoint yourself. But in chapter 6, page 8, how an array can replace nested decisions. We're going to kind of use this concept, but imagine that you were rolling a die and you wanted to see if the die was weighted. How would you find out? You'd roll it 1,000 times or 10,000 times, and you'd see, how often. You'd check to see if one of them was preferred more than the others, right? And if they were mostly even, then you could go, okay, then that's a random die. So that's the application that we're going to write, but it's going to use a concept that's shown here. And so what they've got here is they've asked the user for some data or somehow retrieved something called department. And it's an integer. So department is equal to 0. Is that true? Yeah, then we add 1 to count 0. No, that wasn't true, right? So else. Is department equal to 1? Yes, it is. Then add 1 to counter 1. No. Else. Is department equal to 2? Sure. Add 1 to counter 2. You see where this is going. We've got a whole bunch of these. Is counter equal to 3? Yeah. Add 1 to counter 3. Else. Is department equal to 4? Add 1 to count 4. No. Otherwise, add 1 to count 5. So all in all, they have 0, 1, 2, 3, 4, 5 different counters here. And based on whether the count is equal to 0 or up to 4, it increments the appropriate counter. And if it's none of the above, then it increments a 5th one. Now that's a great big if else cascade, right? We could code that pretty easily, but it's kind of annoying to have to structure it that way if you can't find another solution. So what we're doing there is our application is supposed to produce a count for the dependent categories, for the department categories. And so it uses a series of decisions. But we can automate that decision. Anytime you have code that looks repeated over and over and over, there's probably a way to do it with a loop or some other structure. So here's their code for it, the pseudocode anyways. Just like we described. It's actually dependence rather than departments. If depth is equal to 0, add 1 to that counter. Else if depth is equal to 1, add 1 to that counter, and so on. But instead, we can use an array. And we can have one array element that holds the number for counter 0. And a second array element that holds a counter for 1. And a third array element that holds a counter for 2. Just like cells in a spreadsheet, right? You pop open your spreadsheet. You have, I'm not going to actually, like this, right? Department 0, Department 1, Department 2, Department 3, and so on. We've already established that an array is a series of values that all have the same name. So just like a spreadsheet can have multiple values, all with the same name but differing meaning depending upon their position, we're going to use a variable to do that to tally the departments. So our variable is going to be a subscript into the array. We've already talked about the subscript. The subscript is the index value that indicates which position we're going to be writing into. You know, that's the first entry. That's the second position. That's the third. That's the fourth. We're using zero-based indexing. So that's the index value 0, index value 1, index value 2, index value 3. And by the way, we've been using one-dimensional arrays, but you can have two-dimensional arrays. A spreadsheet like this is a two-dimensional array, really, right? It's got width and depth. But right now we're using one-dimensional arrays, which is just lists of data rather than grids of data. So our array subscript variable is something that is numeric with no decimal places. In other words, it's an integer. It's initialized as 0, and it can be incremented by 1 each time the logic passes through the loop, but it'll never hit the length of the array. It can only go from 0 to n minus 1. So here's our second shot at coming up with a solution for this problem. It's the first one using arrays. Very similar though, right? If depth is equal to 0, add counts subscript 0. Counts is the name of our array. Depth equals 1, add it to counts subscript 1. No. If depth is equal to 2, add it to counts subscript 2. No, and so on. That way we will tally up the number, the count of depth equals 0, the count of depth 1, the count of depth 2, the count of depth 3, and so on. And if you're thinking to yourself that this still looks kind of repetitive, it is, right? This is how they would write it. And then if you wanted to extend it to support, 10 departments, 10 dependents, 20, whatever, you'd have to write a whole bunch more if else, if else, ifs. You wouldn't want to have to modify the code to do that, especially now that we've introduced the idea of using the array here. The array is our tally. Notice the sync between that and that. Department 0, then count 0. Department 1, count 1. Department 2, count 2. That's giving us a clue as to how we're going to solve it. Department 3, count 3. Department 4, count 4. Right? We're just going to use our department number as the subscript, as the index value. So I want to do something similar. Before we actually get to the slide showing the position, I almost hated to erase that. We're going to come up with an application that rolls 2 dice, like that. And maybe it does it 10 times, 100 times, 1,000 times, and it stores in the array, what can 2 dice add up to? 2 to 12, right? So we're going to have a couple of unused positions because we've already, established that all of our arrays start at index 0. But you can't roll 2 dice and get a 0. You can't roll 2 dice and get a 1. But you can at 2, right? And then we go all the way out to 12. So our array is going to have to be how many items long? Starting at 0, going out all the way to 12, how many items is that really? If it was 1 to 12, it'd just be 12. But we have to do zero-based indexing, so that's going to be an array of 13. So what our code's going to do is allocate our array, and then we're going to loop, rolling 2 dice, adding them to the correct place in the array, and then continuing to loop over and over until we're tired of rolling the dice or until we've done it a predetermined number of times. Then we'll print through our array and generate a report. So let's do that. Let's go ahead and load up idle. File new, call it whatever you like. I'm calling mine April 18 for the obvious reasons. My comment here is that it's going to be a dice accumulator. So what's the first thing we need to do? We need to allocate our array. What are we going to call it? I don't know. Let's just call it dice. And I said that we wanted it to be able to support the numbers 0 through 12, so it needs to be 13 in length. So showing that syntax. This is not how you would do it in other languages, of course, because every language is idiosyncratic. But this is how we do it in Python. For example, don't tack this on in your comment, but in Java or C, you do something like this. Dice is equal to new int, like that. And you would say, okay, I need an array named dice, and it's going to have 13 integers. That's the same thing we did here. I'm going to delete that now. But since the book also shows C++ code and stuff like that, I just wanted you to be able to recognize it. Okay, so we have our array. Let's loop a certain number of times. But to use our random number generator, well, tell you what, let's skip the random number generator part and make it as simple as possible and just ask the user for what they rolled, right? So, let's write a for loop that'll ask the user for 10 numbers in a row. For x in range 10. Now, if I do the range statement just like that, with just the one number rather than the 3, what is it going to start counting at? If you leave off the first number, it starts at 0. So that's the same as doing that. And if you leave off the third number, it defaults to what? So doing x in range 10 is the same thing as doing x in range 0, 10, 1. It's going to repeat 10 times, but what is x going to be set to? It's going to start at 0 and go all the way up to 9. And then when it hits 10, it's done with the loop. So it's going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That'll work. If I wanted to print numbers for the user to see, I wouldn't start it at 0 because, users don't think of, I'm making my first turn, so that's turn 0, or, I'm going to go to the first house, so that's house 0. If I was going to display this information to the user, I would want to start it at 1. But I still want 10 numbers to go. Okay, so there we go. 1 up to and not including 11. Let's ask the user for a number. Roll is equal to input. You rolled 2 dice. What was the total? And let's convert it into a number. So roll is equal to float, the float version of the roll. However, that's not really good enough in this case. Why? Because the index value has to be a whole number. Just like you can't move into apartment number 3.2. The apartment numbers are whole numbers, our index values are whole numbers, so we need to turn it into an integer. So I'm going to do this. I'm going to instead make that int roll. And there we go. And now we're going to add into our array that number. And so instead of doing if roll, don't type this, if roll is equal to 0, this is what we could do. Then dice subscript 0 plus equals 1, else if roll is equal to 1. Well, could a roll ever be a 0 on 2 dice? Not really, but anyways, just roll with it. You see where I'm going with this? We could do that all the way out to if roll is equal to 12. But we don't want to do that. Not when we can replace that with just one statement, right? Because that number corresponds with that number corresponds with that, and so on. So all we have to do is say dice subscript at our roll. We could do it long form or short form. You like using plus equals, that's great. If you want to do it the whole way, let's do it that way. Dice at that position, roll, is equal to dice subscript roll plus 1. So if that position was a 0, we're going to increase it to a 1. If that position was a 1, we're going to increase it to a 2, and so on. All right, now we need to print our report. Printing a report sounds like something that ought to be tucked into a module. I guess for now I'm not going to mess with it being a module. Kind of want to. All right, I'm going to make it a module. I'm going to come up to the top here, and we're going to say print dice, and we're going to pass in our list called dice. I'm not liking doing it like this for reasons I'm not going to explain right now. I'm just going to go ahead and do it straight in the body of the code. Okay, so print report. So for X in range, now what's the minimum we said that you can roll with 2 dice? 12. Right, so for X in range, starting at 2, and we want to end at 12, right? So we actually have to go 1 past that. So starting at 2, counting up to but not including 13, adding 1 each time. Print rolled, comma, end quote, comma, X, comma, trying to think of a good way to say this. I don't want to say I rolled 1 4 times. I rolled 2 7 times. I rolled 8 3 times. How about roll equals, comma, X, comma, space, count, maybe a couple spaces, count equals, end quote, comma, and then here we need that value from the array. Dice subscript X. Let's do that. You rolled 2 dice. What was the total? Just a sec. I'm going to try to push this up so that we can have both sets of code on the screen at the same time. Go ahead. All right. You rolled 2 dice. What was the total? 12. What was the total? 7. 5, 8, 9, 3, 2, 7, 6. All righty. So it's asking me 10 times in a row. And there we go. That was my data and that was my results. Whatever numbers you typed in. Now if you typed in something larger than 12, it crashed. So that's because we were using 6-sided dice, and so you D&D players, who were using a 12-sided dice, you would need to rewrite the array. So the right thing to do would be to have our input statement validate the data before we blindly used it as an index. But anyways, so when I was doing this, I said that I rolled any of them twice. Yeah, that I rolled a 7 twice if I look through my data. Yeah, I rolled a 7 there and I rolled a 7 there, so it counted it twice. I never entered any 4s, right? I never entered any 11s. Everything else I entered once. So if you have 2 6-sided dice, two cubes, like normal dice, and you roll them and you add them up, do y'all know which number is the most common one to occur? Seven is the most common one to occur. And why would that be? Because there's more ways to add up. Like if you're going to roll 2 dice, you have lots of combinations, but you could roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. This is actually make a good little thing to automate, right? You could roll a 2 and a 1, a 2 and a 2, a 2 and a 3, and I'm not that it would take that long. 2 and a 4, a 2 and a 5, and a 2 and a 6. And I would copy all that way down right to the last row, which would be 6 and a 1, 6 and a 2, 6 and a 3, 6 and a 4, 6 and a 5, and 6 and a 6, right? I don't feel like adding those other elements to the tables. So, out of all of these, how can you roll a 12? There's only one roll that'll get a 12, and that's a 6 plus 6. How can you get a 2? There's only one roll that'll get a 2. That's 1 plus 1. But how about a 7? There's lots of rolls that add up to 7. 1 plus 6, 2 plus 5, and 3 plus 4. There are more rolls that add up to 7 than any other number. Right? Because a 3 you can roll up in two different ways. A 1 plus a 2 or a 2 plus a 1. A 4 you can roll up in a couple different ways, right? You can roll a 1 plus a 3, a 3 plus a 1, or a 2 plus a 2, and so on. But for a 7, there's lots of different ways. 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2. And if you've taken a statistics course, you could probably tell me how to calculate these percentages exactly, right? So there's more ways to roll a 7 than anything else. So that's why there are dice rolling games, right, where, I think craps or blackjack or something has it to where if you throw, a 7, then it kills your roll. The game is over or something like that. Not blackjack. Anyways, you know what I mean. So let's see if that's kind of true. Let's automate this process so that we're not typing them in by hand. Instead, we're asking the computer to give us the number. It's going to be a random number. And everybody understands why we started at 2. It's because you can't roll a 0 on 2 dice, and you can't roll a 1 on 2 dice. So 2 was the minimum. Okay, so this loop here, we're going to automate it. We're probably going to go more than 11 times. We may go 100 times. We may go 1,000 times. But we're going to need our random library. And it's just about time for me to wander around and make sure that we are all good at this point. Anybody need typo help? We pretty good? Alrighty. What are we going to do? We're going to comment out these 2 lines of code. Right? We're not going to ask the user for that data. Instead, we're going to ask the computer to get it for us. So we need the random library. Import random. So add that line. Import random. Put it above your for loop. And in your for loop, do this. Tell you what, we're going to change that import statement a little bit. That's okay, but what I really want is from random import randint, int, R-A-N-D-I-N-T. And in a minute, I'll show you why I prefer that syntax. So our roll is going to be a random number, roll equals R-A-N-D-I-N-T plus parentheses, starting at 1 and ending at 6, plus another one of those, plus R-A-N-D-I-N-T 1 comma 6. Notice something weird about randint, or maybe it's weird about range. If we do range 1 comma 11, we're going to get a range of numbers from 1 to 10. You might think that randint is going to work the same way, and if we say 1 comma 6, you're going to get the numbers 1 to 5. No. For randint, this actually is the upper bound, and it is inclusive, but for range, it is not. All right, let's give it a shot. All righty, so I only rolled 10 numbers. It said that I got 5s more often than anything else. It said that I never got a 10 or 11 or 12. I'm kind of suspicious of these results. So I want to repeat it 100 times rather than just 10 times. So I'm going to make this 101. All right, that's looking a little bit better. That first one was kind of an anomaly. What do I mean by that? It wasn't centered around 7 at all. It was centered around 5. But, in small numbers, when you're rolling dice, things aren't always the average. How about if we do it 1,000 times? It'd be kind of neat to print these numbers out just so that we saw them being generated. Kind of means something more to us. But there we go, right? We can see that a 7 occurs more often than anything else. Let's do it 10,000 times. Notice how fast it's going. It's looping 10,000 times, By the time you hit the click button, it's practically already done. Computers are fast. And this is a slow language relatively. Okay, so by choosing 10,000, I kind of arranged it so that if we divided the count by 100, it would give us a percentage. So it rolled 7, 17% of the time. It rolled 6, 14% of the time. It rolled 5, 11% of the time. It rolled 4, 8% of the time. Let's make that little modification. Nah, let's not. We're going to leave it alone. But you get the idea, I hope. I'm going to change this back down to a small number, back down to 11, but I'm going to add a print statement so that we can watch it go. So let's just do a print. Round, end quote, comma, X, comma, quote, we rolled a, end quote, comma, roll. You'll see why I lowered it to 11, because if we crank that up and we print out 10,000 things, it's going to take a while. Okay, so round 1, we rolled an 11. Round 2, we rolled a 8. Round 3, we rolled a 6. 4, we rolled a 9, and so on, all the way up to round 10. And then we have our tally. What if we wanted to add up 3 dice, or 4 dice, or 5 dice, or 6 dice? Yeah, there's a couple of changes we have to make. One is that since our total is higher, we'd have to create a larger array. And the other is that we would have to generate that random number more, than just twice. That could be done, done with a loop. I'm trying to think of a way. I'm trying to make it too complicated. I'm wanting to make it to where we could ask the user for how many dice to roll, and then everything would magically happen after that. There are some magic numbers here. Remember what magic numbers are? They're just numbers that appear in the code without really any explanation. The 6 is kind of a magic number. We know that there are 6 sides on a regular cubic die. The more interesting random numbers occur down here, right? Why'd you start counting at 2? Why'd you start counting at 13? All that stuff. So let's define a couple of consonants. See if we can make this make a little bit more sense to somebody else who came along. So we're rolling 6-sided dice. So how about we just say sides is equal to 6. And then everywhere in your code you see a 6, replace it with the word sides. I see 2 occurrences. Now this 13. How did we calculate that? Why did we say 13? Because 6 plus 6, the highest roll, and then one more, just to accommodate, zero-based indexing. So let's do a variable called numDice is equal to 2. And then our dice array will be equal to sides. Tell you what, let's make another one. Max roll is going to be equal to sides times the numDice, right? Because if it's a 6-sided die and you roll 2 of them, the maximum roll will be sides times numDice. And what is the min roll? It's not times the number of sides. It's just equal to the number of dice, right? If you got 2 dice, the minimum roll is a 2. If you've got 4 dice, it's a minimum roll of 4, and so on. So it's equal to the numDice. We've got a bunch of declarations up here. I'm not sure if this is going to make the code horribly more complex or less, but I want to kind of roll with this exercise. This is the kind of thing that you would do if you were writing a program, because somebody else would ask, okay, what if you were generating random numbers between 1 and 100 rather than 1 and 6? Or what if you were rolling 20-sided dice because you like Pathfinder and Dungeons and Dragons? Or, whatever. So we want to make it so that you can change the constants up here at the top and modify the behavior of the program. And I think we've got most of the values here. We don't have a... Okay, let's... the number of dice, or our dice array, is equal to the max roll, but we have to add that 1, right? Because if we want to be able to count from 0 to 6 in our array, it actually has to be of 7 length. So we just have to kind of take it on faith that our array has to be 1 larger than the maximum value of the index that we're using in it. All right, now this counter is just the number of times we want to repeat, really. I didn't declare a variable for that, but I'm going to go ahead and change it right now. How about turns or rounds, right? How many times we're going to add numbers together. So let's declare that. Turns is equal to 10. Although I called it round down here. Whatever. I'll change that word from round to turn in a minute. Before I go any further, let's make sure I haven't broken it yet, and then I want to do walkabout. I've already broken it here. So what have I done there? I need to put this in parentheses. That was my mistake. You see where it says dice is equal to 0? That's the starting value for every element in the array. If we wanted every element in the array to have a value of 100 starting off, we would change that to a 100. All right, so far so good, I think. So for our report, we want to start from the min roll and go up to the max roll plus 1. So you see that range statement down here at the bottom? Min underscore roll goes there. Max underscore roll plus 1 goes there. Now I've taken into account everything except automating it so that if you roll 10 dice, it loops 10 times, right? Doing this part right here 10 times. Everything else should work. I'm going to change that 10 to 100 just to watch it go further. How many dice, how many turns do I want? 100. And I'm pretty sure now that some folks need an extra pair of eyeballs on the screen. So these are interesting results, but random numbers are random. You can't really predict them. So yeah, we did roll a 2 more often than we rolled a 3. And really, this should follow what's known as a bell curve. Maybe you've heard the term bell curve distribution, where you have a high value in the middle of your curve and you have low numbers at the end. Bell curve dice distribution. Hey, that's kind of neat. Any of you game players might like this site, anydice.com. You type in the number of dice that you're rolling and the size of the dice, and it generates a probability for it. So, right, 7s get rolled more often than 2s. If you're rolling 3 dice, 3d6, this is a cool idea for a program. I like this. Calculate it. Looks a little bit different. The numbers 10 and 11 are the most commonly rolled if you're rolling 3 dice and adding them up. Huh, alrighty. I like that program. Okay, bring the code back up, pause the camera. Make sure everybody's got it. Alrighty. The next I'm going to leave is a thought problem. I'll show you all the answer, but it would be awesome if a couple of y'all got the answer as well. And the question is, this is code for rolling 2 dice. But what if I set num dice equal to 3? What if I set num dice equal to 4? I'm going to kind of isolate this code right here, comment that out, and take a stab at writing some code that would do what we would want. If num dice is equal to 2, it's going to add up 2. But if num dice is equal to 10, it's going to add up 10. Just work on that for a couple of minutes. If you think you can, and if you can't and you want to wait for me to give you the answer, that's fine. But I still want you to think of how you would do it, even if you're not going to type it. What kind of programming structure would let you do something 2 times or 10 times or 100 times? A loop, right? So you're going to use a loop. I think I would use a for loop. All right, just a sec. I need to check Mind tab. Apologize. And it's okay if you don't get it, but I'd be real proud if somebody did. This is more like a homework assignment where, theoretically you might have to work on it for quite a while to figure it out yourself. Okay, so I want to add up a predetermined number of dice. I could use a loop to do that, right? Like effectively, if number of dice is equal to 2, I want it to count, 1 and 2. If number of dice is 12, I want it to count from 1 to 12. Adding my rolls up all along. So, this, it turns out, is our accumulator, right? So it has to start at 0, and then we have to start tacking things onto it. So I guess I'm going to call it total for now to make it a little easier to spot. Total is equal to 0, and then I need a for loop. For x in range, no, I better not use x again because I have x here, and you shouldn't use the same counter in more than one place. So this is kind of lame, but I'm going to call it y, right? Alrighty, and if I want to roll 2 dice, if I wanted to loop two times, I could just put num underscore dice there. Right? Because that would repeat 2 times. It would count 0 and 1 if num dice is equal to 2. If num dice is equal to 10, it would count 0 up to 9. All right, and then so our total is plus equals rand int 1 comma sides, like that. And then our roll is equal to our total. All right, I think it worked. I'm going to modify it so that we are rolling 10 dice rather than 2. So our numbers are much higher, right? Our average are, because if you're rolling 10 dice, your minimum is 6 and your maximum is 36. So we have a much broader, I think I've busted it. This doesn't look right. Oh, I said 10 dice, right? So its minimum is 10. And its maximum is 60. And since we're only doing that a certain number of times, then we're not getting every one of them covered. Now, I don't know any game where you roll 10 dice. It's kind of hard to keep track of. But what if we're rolling characters in a role-playing game and you need 3 dice? So change num dice equal to 3. And in this case, the minimum, the smallest, the least rolled should be 3 and 18. That's why it's so awesome in D&D if you roll a character and he's got attributes of 18. There you go. All right. Yeah, we can see that we almost never rolled a 3. And we rolled a lot of 10, 11s, and 12s. That's to be expected. I think the last thing that would be cool to add to this would be to make one of those little bar charts, just like we saw in that program. How would we do that? Each one of these would be a loop. Print out 1 asterisk. Go to the next line. Print out 2 asterisks. Print out 3 asterisks. Print out 4 asterisks, and so on. The only thing we're going to have to take into account is that when we're trying to line everything up, sometimes we have 1 space here. Sometimes we have 2 spaces here. There's a way we can fix that. And I need to demonstrate that to y'all. There is something called a formatted print statement. And yes, we have gone off away from what the book covers here. But that's all right. Y'all want to learn how to program. You don't just want to learn how to read a textbook. So I'm going to show you what a formatted print statement looks like. Say I have a number. X is equal to 3.14159. And y is equal to 7. Let's print some numbers. Print x equals, and what if I like pi, but I only want it out to 2 places? So I'm going to use a placeholder, which starts with a percent sign. All these placeholders start with a percent sign. That's a special code that we're putting inside the print statement to make it a formatted print. And we're going to say, okay, I want this number to occupy 5 spaces on the screen, and I want it to have 2 decimal points. So 5 wide, 0.2, 2 places after the decimal place.
What is that?
That's a percent sign. That's a shift 5. Okay, and after that last quote, we don't put a comma like we have been doing. Since it's a formatted print, we use a percent. And this syntax is a little bit different in Java and some other languages, but it's going to introduce you to the idea. Oh, and I messed that up. There was something I forgot. Percent 5.2f. Why do I put an f there? Because this is a floating point number. If it was going to be an integer like this, I would actually put d. I don't know why they chose d rather than I, but they all do. I guess for digits, whole numbers, not sure. Okay, and then we're going to put our number, the value that we want to print, right? X. And it runs its rigmarole, but we see here it's occupying 5 spaces, right? From there to there. Actually, it looks like 6, but that's because I had a space there, right? If I take out all the spaces in my print, and heck, I don't know, star star in front of that percent sign and star star after the F, that'll show real blatantly how it formatted it. So when it printed it out, right, it printed star star and then it left 5 places for that number. And so it printed that number formatted to 5 places with 2 decimals. If we only want 1 decimal, we could change it to 5.1. If we wanted it to have 6 columns on the screen, 6 spaces, so 6.1. And there we go. So it's occupying 6 spaces now, right? But it's only got 1 decimal point. What if we didn't want it to have a decimal point at all? How about 0.0? Let's see if that'll work. Not 9, 0. And there we go, right? It printed out pi with 0 decimal places, which is actually 3, and it padded it out to 6 spaces. We're going to take advantage of that. Now, why did we do all that? Because I said we wanted to create a bar chart, you know, with asterisks rolling across the screen. But the bar chart would be distorted if some of the numbers only had 1 column in front of them. Some of the numbers had 2 columns because we were in the, 10 through 99. And then if we went up to the hundreds or whatever, we'd have 3 spaces. So we're going to take advantage of that print. What I'm curious about now is whether we could pass in Y rather than X here and have it printed out correctly. What if that's a Y? It should print out 7, right? Yep, it did print out 7. What if we said I want it to 2 decimal places? 6.2. Okay. And print it out to 7.0. So, all well and good. We could have used that to calculate percentages, right? And print them out nicely. We could have used some formatted print statements. But I wanted to introduce the idea slowly. So, here, we're going to change this print statement to something that looks a little bit different. And aha, there's one more thing I need to show you. What if you have 2 pieces of data, but you don't want them printed on separate lines, right? Like, print your first name on one line, print your last name on a second line. But I really want them on the same line, right? I don't want them to say Jeff on one line and then Thompson on the other. I can modify the print statement like this. End equals space, like that. Be sure, use double quotes and put a space between there. What that does is it means, oh, when you hit the end, don't hit enter. Instead, just space over 1. If you wanted to space over twice, you could put 2 spaces there. If you wanted, to have a question mark there for some reason, you could do that. But let's run it now and see if it prints my name on 1 line rather than 2. All right, it did that. So here's our report code, right? Just comment that code out. We want to keep it around so that you could reference it if you wanted to in the future. And we're not going to need all this formatted print stuff at the end, so we may as well comment that stuff out as well, just to keep the concept of it, though, hanging out. All right, here's our new report. The first line is going to be the same. I could just copy it. I think I'll do that. It's easier than typing it all, right? So the first line of my report, I'm just copying, pasting, and taking out the comment tag. Now I want to print the number that they rolled, but I want it formatted to like 3 spaces. So print roll equals percent 3.0f end quote, comma, and what's the data that we want to do? That's going to be dice at subscript x. And I know we're at the point where some people are just typing code because they see me type it and you're not totally understanding it, and that's okay. right? Because before you learned how to play football, you watched a lot of football, right? And so at some point, we're just kind of participating in it, getting some ideas down without understanding every single thing we type. And I hope you don't mind that. I hope you understand why sometimes I introduce things before, without lecturing on them for 30 minutes first. Okay, so we've printed out the number, right? That's the first thing. But we don't want it to skip to the next line before it starts printing those asterisks to indicate how many rolls. So I need to tack on one more clause. End is equal to a space. Like that. End is equal to quote, space, quote. And now I need a loop. Or at least I need to print a certain number of stars equal to that dice. Now Python lets us do that in a squirrely fashion, and so I'm going to take advantage of that. Otherwise, I'd have to do this. Don't type this. I'd have to say for x in range, dice, subscript x. You could type it if you want it, but I'm just going to comment it out. And then print an asterisk, but don't go to the next line. Right? Like that. Now, I didn't put a space there because I don't want to put a space between each asterisk. That's one way I could do it. But I think I could do it in a faster way. Print one asterisk, but repeat it the required number of times. So this syntax, and if you don't like asterisks, we could print another symbol. You like at signs or hashtags? Whatever. Okay. Print £1 but repeat it the number of rolls. I think that'll do it. I think that'll make a pretty report. Alrighty, I goofed. What's the difference between what I did here in this print statement? I want somebody to spot it. And down here where I showed us how to use a formatted print statement. There's a key difference. Yeah, you see that right there? I needed that symbol rather than a comma. And I apologize for making that mistake. That was not my intention. So, look at this statement. Change that comma there to a percent sign. That's the statement that we just modified. And there we go. There's our little bar chart. That's rolling 100 dice. Let's roll 500 dice. Just scroll up and change the number of turns to 500 and run it again. And then I'll do walkabout, make sure we're all good. All right, now that one actually went off the screen. It was so many times. We should try to accommodate for that. We should divide our rolls by some factor to make sure that it fits on the screen. I could take out this word roll equal and then just print, Am I rolling 4 dice? Why did it start at 4? I thought I was rolling 3 dice, but it's starting at 4. Oh, I never printed out X. That's what the deal is. It's just printing out this data again, right? 4, 7, 9. One more change we have to make, and I apologize for having made 2 mistakes. You see this line that says dice X? I just need to print out X itself, because that's the die roll that we're currently looking at. How many 3s did we roll, then how many 4s did we roll, and so on. So there were 2 mistakes in that. So make sure you examine what you've typed and what I've typed real carefully on that line. All right, it still has the problem of going off the edge of the screen. So I'm going to take the word roll equals out of it. Right. The real answer would be to divide it by some scaling factor. But I'm going to remove roll as equal, and it's just going to start with that percent 3.0f. That's the last change to that line, I promise. All right, so that's a pretty good bar graph. It'd be neat to change it to percentages, so that we could see we rolled 10, 20% at a time, and we rolled at 11, 30% at a time, and stuff like that. But I think we've gone far enough. We've probably gone too far. if we look at our code without all the comments, it's not as long as we think. I'm just going to copy all this code and I'm going to remove all the comments, right? You don't have to do this, but I just want you to get an idea that the code is not as complex as it looks with all the comments added. So where did I restart it? I restarted it here. Okay. So I'm going to remove all the comments from this stuff. We don't need those three things. I like that one. Print and report. It tells us what we're doing. We don't need those 2 lines of code. There we go. From there to there is everything that we've done without all the stuff that we removed. So it's fairly elegant at that point. It's fairly concise at that point. We ought to document it a little bit with comments, like I should say what this loop is doing. Roll the required number of dice, the required number of times, and keep track of the totals in an array. This is actually called a histogram. A histogram is when you're keeping track of categories. I sold 3 cars, bum, bum, bum. But I sold 7 trucks, bum, 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 bum. And I sold 9 airplanes, bum, 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 bum. That's a histogram, right? A history of how many trucks and how many cars and how many airplanes. All right. Let's queue. So this goes into Dropbox queue. Pause the recording if you need more time to type it in. This has got everything except for the declarations up at the top. So if I remove our comments and everything, maybe I can get it all out in one line. There's no minimum. It's to your advantage to be here, but if you miss a day, just watch the video.
Yeah, I was just filling in the weather, and I feel like I'm up to 3 hours.
Got it.
So
Yeah, yeah. I'm not going to count you. I'll just keep up with the videos. All right, that's our final version. So, see y'all next time.